Hey folks, welcome back to Mark Kelly Farm. Before we get to today's much anticipated video about building trusses for our chicken coop or whatever you're building, let's welcome our new subscribers to the channel. We got James McPherson, Paula Kay, Sandra Howington, Buzzsaw 161, Terry A. Sullivan, Karen Quinlan Hall, 15 Speedy 23, John McGowan, and Gary Morish. I hope I'm pronouncing your name correctly. It could be Morish, I guess. But welcome to our channel. Stay tuned for some good recipes and some good down-to-earth, back-to-basics kind of channel. We hope you enjoy it. Hi folks, welcome to the chicken coop. We're almost dried in, and I wanted to do a, I don't want to say rafter, but a truss video, or a building your roof video kind of thing before we got too far along, but things got busy, so I'm going to stop and do it now. So we're going to cover how to figure out what you need for trusses, how to build them if you want to build them, and so on and so on. So if you remember, our chicken coop is 8 foot wide and 16 feet long. Most of your trusses or rafters, ceiling joists and such are on 2 foot centers. So for a 16-foot building, common thought would be you just divide that by 2 and you'd come up with 8, but you need one more truss for one of the gable ends. So for the 16-foot building, you actually end up with 9 trusses. So you'd have to either order or build 9 trusses. So most lumber stores like Lowe's, Menards, Home Depot and all that have commercially built trusses available at standard lengths, like 8 foot, 10 foot, 12 foot, and such, and so on and so on. And generally they'll have like a standard roof pitch, but some of them do offer different pitches on the roof as well. Generally, from your location, they'll pick like a general roof pitch for the location. So if you're in like a snowy area where they got a heavy snow load, the pitch of the roof will probably be a little bit steeper. So they kind of look at the geographical area when they come up with your standard trusses at those stores. So you can buy those trusses at the store. You just tell them how many trusses you want and how many gable ends you want. Generally, there's only 2, one on either end. But if you have like a change of direction of your roof or a dormer sticking out, you would obviously need another gable end truss. And what we mean by gable end truss is that end truss right out on the end of the wall. Our gable end truss is the same as all of our rest of our trusses because this is such a small building. Usually your gable end trusses will have a lot more vertical supports in them. So when you put your siding on, you would have them like 2 foot on center in that truss. Your center trusses do not need that because there's no siding attached to those. So let's go over the different parts of the truss. So this is the bottom chord of the truss, which doubles as your ceiling joist on the inside of the building. So if you're putting a ceiling, that's what you'd nail or screw your ceiling to. And then you have your rafter portion of your truss on either side. And then you have your king post of your truss. And now if your truss is wide enough where you need more support, you would have what's called a strut in here. And sometimes there's more than one strut if it's engineered. So basically with this thing all tied together and with your struts in place, your strut adds support to that outer portion of the rafter if it were to get too long. And being this is tied together here, That holds everything together nice and tight. Now, your ceiling joist or your bottom cord also actually serves to hold your walls together. So, not so important here out on the edge, but you can imagine when you get to the center of the building, your walls are going to kind of want to bulge out because of the weight of the roof. Because the weight bearing down on the roof this way, if you didn't have this tie across here, this would want to come down and push the wall out to try to flatten itself out. So that bottom cord kind of got double duty as a ceiling joist and holding the walls together. So we're going to talk a little bit about angles now. Now, there's different pitches of roof, obviously. Some are steeper, some are shallower. The steeper the roof, the more load bearing you can get, because more of the weight is being transferred down onto the outside load bearing walls. Also, you have better drainage off of that roof, obviously. When you get to the flatter roofs, they're not going to drain as readily. So if you get a real flat roof, say up over a patio or something like that, that's going to play into what kind of roofing material that you use. You don't want to use composition shingles, I believe, for anything under like a 312, because the water just doesn't run off as well. But I'm sure you could pull it off. I don't know what the codes are in your area. You definitely have to check those as far as what type of roof you can put on what different pitches of roofs. But I would recommend on the slower or the lower pitches to go with a metal roof. That way you're not going to have any leakage or anything like that. And on a small building with the corrugated metal that they have today, you can almost go with a flat roof and the rain is still going to drain off of it, as long as you don't have any big dips in it. But I try not to go flat whenever you can get away from that. Stay away from flat roofs. At least have a little pitch in it to where the rain will run off. But let's go over a little diagram of how the pitch angles work, and I'll explain them to you a little bit. All right, let's say this is your common rafter. So when you talk about rafters or trusses, you're going to talk about pitch of roof, which is measured in 12s. You have 112, 612, 212, 312, 412, whatever, all the way up to like 1212, where you can go beyond 1212, but that's a pretty darn steep roof. So 1212 would be 12 inches vertical for every 12 inches horizontal. So in a 12-inch run or a 1 foot run, you would rise 1 foot, thus giving you a 45-degree angle. So your 12-12 pitch is a 45-degree angle, which again is very steep. You'll see that on like mountain cabins and stuff like that because of the snow load and such. But generally your houses are around 612 pitch, which would be half of your 1212, which instead of being 45 degrees, it would be 22.5 degrees, which is half of that, correct? So that's what it would be. So say we wanted to do trusses for an 8-foot building, and we'd want to do it on a 612 pitch. Just to give you an idea, our chicken coop is a 412 pitch. If you've seen that in the videos, if not, you'll see it soon. So say you want to build a truss. You know this measurement here is the width of your building. So you know your bottom cord is going to be, if your building is 8 foot wide like ours is, your bottom cord is going to be 8 foot wide to the long point of your angle cut. So let's talk about how to find your angle cuts. So there's some different tools that you can use. This is called a squangle or a quick square. Now this is called a squangle, excuse me. This is a quick square. So as you see on your quick square here, this is the pivot point of your square. So this is what you put on your wood. So say you wanted to do a 6/12 pitch, you would go to the common rafter area here, and you'd pull that out until you reached 6/12. So this angle right here would be your common rafter cut for your 6/12, which would be this cut right here. So your two rafters need a 6/12 cut on the end. Now, this angle down here for your bottom chord is going to be a lot less steep of an angle. It's called a back cut. Now, the quick square does not give you the back cut. However, if you know the degrees, and you can just Google it, what's the back cut, what's the degrees for a back cut of a 6/12 pitch, and it'll tell you, and then you can actually just do the degrees out here. But on the squangle, if you have this set, I think this is a 4/12 for me, but say this was 6/12 set, and you read it right here along here. This one's kind of wore out. I used it years ago in construction, so you can barely read it. You have your 6/12. This actually gives you the back cut on the back side right here. So if you wanted the back cut, that's the back cut for a 6/12 pitch right there. Most of the time you'll have to extend that line because, you know, this section of the square here is not long enough to give you your whole cut. But you would just set this on here, mark it, and then just extend this line with a ruler, and that'll give you your back cut. So when you have your 8-foot length here, you would start your 8-foot right here in this corner, right there, and this would be your back cut. And then you'd flip it around and do your back cut for the other side. Okay? And you know, again, that it's 8 foot long. So your bottom chord is done now. So now, there's ways to figure out your rafter length. There's calculators online to figure that out. You give them the different dimensions and they'll tell you how long of rafter you want with your overhang included and all that. But you don't have to go to such great lengths to figure that out. Say, like for mine, we had right around a 6-foot rafter length. So a standard 8-foot 2x4 is what we used because they're cheaper. So I just took two 8-foot 2x4s. I put our 6/12 cut on the top. So you'd put that on a piece of board, and there's your 6/12 cut right there. And then you just run these two boards together. And then you'll measure from here to the bottom and make these measurements the same on both sides. And then that'll show you how long your rafters are out here. And then you can decide how much of an overhang you want past the building. I used, we had 6-foot roofing panels that we bought. So I stayed shy of 6 foot because we were going to put a fascia board here. So we went about 5 foot, I think it was like 10.5 to allow for that fascia board plus a little 1-inch overhang of the metal. So just figure out how far you want your metal to overhang and whether you're going to have a fascia board or not. And I'll explain to you what a fascia board is here in a second. So that'll give you your rafter length. So you can cut all your rafters the same length once you figure it out. So then once you know what this measurement is, you can go ahead and mark this measurement on both boards. And there's two different cuts you can do. I showed a plumb cut here, which is basically just another 6/12 cut on the bottom. So that makes a plumb cut. Or you can do a square cut on the end like this. So it's whatever you desire. You can even put fascia board on it with square cut. Remember with the plumb cut that this measurement here is longer than the 2x4. So if you stick a 2x4 here and flush it up here on the top, you're going to have this little point sticking out down here. But you also remember too, if you're doing a 2x4 here, you've got to hold it down a little bit when you get to your fascia board, because otherwise if you put it clear to the top, when your roofing comes down, it's going to hit right here. So you would actually hold it down to where your roofing comes down and clips that corner. But you'll probably still, you just clip that little bottom off of your in rafter there. Works just fine. So once you make your measurement from here to here, make marks on both of them, you know exactly where your bottom chord's going to hit. And then you just run your top together. I put a couple screws or nails in it. I put a screw up through this way, screw up through this way, and a screw across this way. And that kind of holds it together until you get your fasteners on. And then you can determine how tall your king post is going to be. Just lay a 2x4 in here and mark it up underneath if you want, or just measure it. What you got here is this is just a half of a 6/12 on both sides. So you go to the center of the board, you cut a 6/12 this way and a 6/12 that way, and that fits right up in there like that. And when you make your struts, you want your struts to be a square cut on the end at all times, because a 45-degree angle, or whatever the angle is of that rafter, that square cut bears the load the best. So I would come in right to the bottom of your king stud. You can either split it here, which enables you to put a bigger mounting plate here and tie all this together, or you can just, run it from there. This is the preferred method, so you can put a big plate here and tie all that together. But that's how you build a truss. I hope it's not too confusing. You can find these angles if you don't have a squangle or a fast square or speed square. There's other types you can use. This has all your angles on them. You just have to keep in mind that sometimes your degrees, depending on which side of 90 degrees you're on, will change. Like this one here goes from 5 degrees to over 45 degrees, 75 degrees, whatever. Whereas this one goes from 0 degrees all the way to 180 degrees. So you just have to figure which side of 90 or which side of 0 you're on, and sometimes those numbers will change. Now, the only time that you deviate from the standard angles is if it's a hip or valley truss that you're making. So let's pretend we're looking straight down from the sky onto our roof. And you have your peak that goes down here, just a rectangular building. So say you had a part of your building that stuck out this way, and this part of the roof went like this. So you would have what's called a valley right here. So if you're cutting a truss to go from here to here in your valley, that's called a hip and valley cut. And if you have the tri-square, you'll look on here, this is your common rafters, and these are your hip and valley rafters. Because that rafter is a lot longer, it's not going to be as steep as an angle as your common rafter. So if you look at like a 6/12 on this side, doesn't line up with a 6/12 on that side. So that is a 6/12 valley cut, where that is a 6/12 common rafter cut. Because this rafter is obviously a lot longer than a rafter that would just go from here to here. That's why your angle changes. So that's the only difference, but that gets a little more complicated. But like I said, even if you don't have one of these squares, you can Google what is the angle of a 6/12 rafter cut, and it'll give you the actual number of the angle. So as long as you got a square, that'll just give you the degrees. Like out on here, it has the degrees on the very outside. So say we're looking at 22.5 degrees, There's 22.5. There you go. That actually lines up with 5/12 still. I thought 6/12 would be a 22.5, but whatever, however that works out. So you can do the degrees out here as well. So let's talk a little bit of old school. So your old school framers would use what's called a framing square, and you've probably seen them. This is a big, gigantic framing square. Well, this framing square does a lot more than just give you square corners, obviously. Because our measurements are on this square, and remember, our trusses are measured, or roof pitches are measured, how many inches rise you have for every foot of run. Remember, 12 is 12 inches high for every 12 inches of run. You can measure all of your other pitches on here as well. So you'd go to 12 inches and you can go to any inch along here. So 12 inches of run and say 6 inches of rise for a 6/12. If we set our square here on 12 on this end, let's do it on the back side so it stays on the board. So we'll set it to 12 here, and we'll set it to 6 down here. Get it correct here. So there's your 12 inches, 6 inches. So this is your 6/12 cut. So say you threw your speed square in here and you pivoted it. Let's come down a little further so I have room on the table. So 6 and 12. So if you were to take your speed square and set it on 6/12, see, there's your 6/12 cut. So you can do it with the old square, and guess what? Your back cut is the long side. So there's our back cut, same thing. So if you have a big framing square, you can use this to do the same thing. Just set it on 12 inches, and then what your rise is on this side, just make sure if you're using the outside here, you're using the outside here. If you're using the inside, make sure you use the inside there. But you can do this with a framing square. And this framing square does so much more. I highly recommend you look up maybe on YouTube different ways to use a framing square. There is so much you can do with this square as far as measuring. And a lot of your older squares, this one does not have it. But a lot of your older squares will have your formulations for your hip and valley and all that written right on the square. All kinds of different formulas. The old-time framer guys use the heck out of these squares. And they're still real valuable. If you don't have these, this really does both. So it works really nice. Plus, like when say you're measuring even a piece of plywood to cut, you go on your square end and then you can mark anywhere up on this. And then you can even run your mark down the board if you want. Or if you're just cutting the square out of the corner, you just go however many inches you want this way, make your mark, and then however many inches your other way. Say you want a rectangle, you can make your mark that way. So really handy. But that's the way the old school guys used to do it. And you can walk this square down the way. You can make treads for stairs with these things on your board. Say you got an angled board and you want to make your stair treads. You just walk this thing down there, making your marks for your stair treads on your supports for your stairs. But lots of things what you can do with these, and like I said, Google that on YouTube or look it up on YouTube. Buy you one of these squares. They're invaluable. I hope it's not too confusing doing those angles. So you have different options when it comes to tying all that wood together. Like I said, just tack it together. You use some like 3-inch screws, go up through those corners. So what I purchased to put these together, and it's just one option, are these nailer plates. And they make them in all different sizes. So here's a larger plate. Here's a smaller plate. But get whatever size you need. If you're tying in something like this, they make bigger plates than even this, where you'll cover all of those joints. And then what you do is you get some nice 1.5-inch flathead screws, as flat ahead as you can find, because you're going to be like paneling or siding stuff over the top of these. And then you just pick some holes that cover all those pieces and drill those screws in to hold everything together. And you do this on both sides of the truss. So do one side first, flip it over, and then put it on the other side. Now the other thing that you can use, they have the actual nailer plates like the regular trusses come with all the little prickly spines on them that you put on. You just hammer them down with a hammer to get all those little sharp points to go into the wood. People have been building with those for years, but I've never used them at home, because at the truss places they have like a big hydraulic press that comes down and presses those into the wood. But I've never done it with a hammer, so I don't know if it works or not. But there's other ways you can do it. You don't even have to use metal. You can cut pieces of plywood like we got here, some spare pieces of plywood, and cut some gussets at the same angle that cover all this, and just put some screws into the plywood. Cut a plywood gusset for that, and down here get a big like square piece of plywood and put all those screws in to tie it all together. Same over here. The only thing that's going to be hindered here is when you anchor your truss down to your wall, and I'll show you how that works in a little bit. If you're using hurricane ties, if you use plywood down here, the hurricane tie is not going to go around all that unless you can find one that's maybe wider. But that's how you put your trusses together. Now, if your trusses are small enough and you have a big enough surface area, like a big piece of plywood or something, you can actually set up, like if you had these small trusses, get a piece of 4x8 plywood, and you can set up a jig by screwing like 2x4s down that you just set your boards up against and throw it all together, so there's not a lot of measuring and stuff. But I found it easiest just to measure from here to here and make the marks, and then we could put this together right where this comes together and it just screws right together. It's pretty easy. So let's go look how to fasten these down to the wall. Now I must tell you, trusses are not the only way to build a roof. It can be built in place. So instead of buying or making trusses, you would basically piecemeal it together actually on the roof. It's called cut and stack. So basically you'd put in your ridge beam and support it on every wall or whatever. And then you would cut individual rafters to go from the edge of the wall up to the ridge beam and tie together. And all your rafters, of course, would be the same length. So that would automatically center your ridge beam. But if you're doing rafters like that, it gets a little more complicated, and I don't recommend the novice or beginning builder to do that, because the right way to do it is do what's called a bird's mouth cut and stuff like that, so it sits on the wall flat. And then you still have to add in your ceiling joist and stuff like that. Most people just nail the ceiling joist on the either one side or the other of the rafter. But it's just easier to build these simple trusses, and I recommend that you do that. So here in our building we used, it's called a hurricane tie, and it's supposed to hold your roof on in the event of a hurricane. But of course, if you get a tornado or a hurricane, you'd be lucky to have your building survive through it. But these hurricane ties that we purchased are wide enough to go over both of those plates. There's one on both sides. And what we did is we shoved the hurricane tie up onto the truss, and we lined up one of the holes and put a screw all the way through both plates. And then we screwed 3 screws down here onto the sub plate and the top plate. And then obviously these plates aren't going to line up perfectly. So on this side I just got a drill bit that had the right connection in my driver drill, so I didn't have to use 2 different drills. And I just drilled a little hole through the plate on the truss and then ran the screw in there. And it was real easy, wasn't hard at all. But that ties your rafter down to the structure itself. And we've got those hurricane ties all the way around. Now we have a different hurricane tie on your gable end on the outside. It's a different style. It's just got 2 angles to where it screws to the wall. And if you're screwing to a truss, it'll actually make a 90-degree turn. But you can get flat ones too. You can even use some of these plates and just run a plate down on the outside of the wall and tie it together that way. But up here on our center wall, what I did here is I just cut one of our hurricane anchors in half and then just used the 90-degree angle piece to tie these center trusses down to the wall. So let's look on the outside what we have to do once we get our trusses set. So once we get all our trusses set, we have to add what we call bird blocks. And they're the blocks that go in between the trusses and keep birds or whatever else from going up into your roof, because you have that 3.5-inch gap there. And I usually set those bird blocks just off of where they meet the wall. That way if somebody's putting the wood up here to cover the eaves, you have a nailing surface up underneath there. Plus when you put your siding on, when you rub your siding up against that bird block, it seals off that area too. But those are called bird blocks, and if you set all your trusses on 2-foot centers, on center, all of your bird blocks are going to be 22.5 inches long. Some people will have their bird blocks pre-cut all at 22.5 inches, and then you set your gable end truss and you just use your bird blocks for your spacing, and it comes out pretty darn close as long as you're a good cut. And that saves you a lot of time to have an individually cut, all those bird blocks, because if you just do it with a tape measure, chances are you're going to be 1/8 of an inch off here, and then by the time you get down to the other end, you're 1/4 inch off and such. So if you use those bird blocks to do your layout once you lay in your trusses down, that's probably a good way to go, and everything stays nice and tight. You may have to fudge that end block just a little bit if there was something off by the time you got down to the end. Just fudge that end block, make it a little bit longer, a little bit shorter, or whatever. Now when you stand your first truss, I screw a 2x4 on the outside of the wall on edge. That way when we stand that first truss, it leans right up against that 2x4, and I put a temporary screw into that, and that holds that first truss straight up and down. And then we keep standing trusses, and then eventually I'll throw a purlin up there, which is what these boards are right here. These are called purlins, and that's what your roofing screws to. Some people do full sheeting up there, so like if you're going to do composition shingles, you would have full sheeting like OSB or something up there on the roof, and you wouldn't use the purlins. But we use the purlins because we don't have to screw that sheeting down like every 2 inches or anything. So we got those purlins about, I would say about 2 feet or so. The measurement that I use is I make sure I can get my body up through between the purlins, because when I put the roof on, I put it on one sheet at a time, so I don't have to stand up on the roof. I can do it from a ladder. So I'll lay the first sheet, and then I'll screw it down, and then I'll back my ladder up, lay the next sheet, screw that down, and so on. So that's why I allow enough room between the purlins to get my body up through. And then when we do the last one, we just do it from the ladder on the outside of the building. Now this other board you see here is used to tie all your bottom cords or your ceiling joists together. That's generally known as a rat run. And I'll usually take my rat run while it's still on the ground, and I'll make my 2-foot on center measurements on it. And that way when I throw it up in here, all I got to do is make sure that ceiling joist or that bottom cord is lined up with that mark, and then I can screw that down. And that just ties all of our ceiling joists together and keeps them from moving around and keeps them on the correct spacing. Now, if we had a lot wider rafters, we would need more of these rat runs every now and then. So if say we were at a 10-foot wide building, we may want to put 2, or say you got a 20-foot wide building, you know, put one like every 4 or 5 feet, and so on and so on. Now, normally you would put some diagonal bracing up in here, but if you use solid sheeting, once you get everything screwed together and everything's plumb and true, that 2x4 keeps it straight. Once you screw the solid sheeting down, these rafters aren't going to rack one way or the other. It stays pretty straight. But some people will still come in at the bottom of this truss and put a 2x4 on edge from the bottom of this truss to the top of the next truss, or even come through, nail to the side of this truss and then to the top of this truss, running a 2x4 from here through here all the way up to there. And that keeps your trusses from racking this way and that way. This building is so small, we really don't have to worry about that because the sheeting ties everything together. But say these trusses were like 6 feet tall, because the building was so tall, you would definitely want to put those angle braces in. And you would also, on your struts, if you had struts in your king post, you would put rat runs maybe halfway up across those to tie everything together, just to keep things all in line. But that's how you set your trusses. And then we usually put the double purlin up at top, but we didn't do that. But normally folks will put 2 purlins right next to each other on both sides, so you'd end up with 4 on the top. And when you put your ridge cap down, that gives you plenty to screw to. And you can see those longer screws coming through those purlins from our ridge cap. But if you've got a wider ridge cap, you can double up on those purlins up top. Now your first purlin needs to start right on the edge of your bird block out there. And what that does is it closes the gap between your bird block and your roof. Because otherwise, if you didn't have a purlin right there on top of that bird block, you'd have a 3/4 inch gap going through there that you'd still have to fill. So start your first purlin there. Now these metal roofing panels, they have closure strips that you buy, and there's an inside closure strip and there's an outside closure strip. So your inside closure strips you would put on top of this purlin, usually flush with the outside of the wall, and that closes all of these little gaps underneath the ribs of your metal roof. So there's no air gaps where bugs and stuff can get in. Anybody that's in a wasp area will realize that they would be traveling in there pretty good. So those are the inside closures. Now they make an outside closure, which is used up top. It goes on top of the roof to go between your metal roof and the ridge cap. So instead of having humps in it, it's actually got cutouts in it to go over the top of those ridges. And it's just the opposite. They have sticky on one side. So they'll actually stick down to the roof, whereas your inside closures actually stick down to the wood, and you put those up as you go along putting the sheets. I was putting the outside closures also on as I moved along, so I didn't have to crawl out on the roof and put those in. As I went along, I would put the outside closures where they needed to go on top of that sheet. But we will get into the roof sheeting video next time in our next installment. I just wanted to cover the trusses today. I hope I've covered all of your questions that you may have for building trusses. It's not hard. and it's a lot cheaper than buying pre-built trusses. But if you're not comfortable doing it, the pre-built trusses are out there and you can purchase those. But just make sure you have everything you need and everything is tied together real nicely. On those king posts, those are a little bit easier than the struts, but if the angles get you all messed up on the struts, just lay the strut where you want it to go, get up underneath and mark it with a pencil if it gets too crazy on you. But like I said, if you keep that top cut square, the bottom cut should just be a mirror. Say you're doing a 612 roof, the bottom cut would be 612. So that makes it a lot easier if you make that top cut square. Now out here on the end of the tails is what we call them. These are the tails of your rafters. There's another purlin out here to hold the edge of your roofing. And as you can see, when we did our fascia board on the outside, we held our tails back 1.5 inches so we can fit a fascia board right on the inside of that outer fascia board, because when you're looking from the end, you don't want to see a splice. So it's going to splice in this way. It's not so much important from the side. But we're going to screw our fascia board right to that, and it's going to go 16 feet all the way down to the other end and be screwed to the end of all these tails. Now on this roof, on the gable ends, we did not go with an overhang. All we put was just a fascia board on the ends to close the gap between the purlins and the roof. So that fascia board was moved up just to the top of the purlins, and then that left a little nailing section underneath. So we moved up 3/4 of an inch to be the top of the purlins, so that left 3/4 of our rafter, 3/4 of an inch, to nail our siding to here. But there's a way to get an overhang on your gable ends, and we'll show you how that works. Okay, say you wanted an overhang on your gable end. Generally, your overhang's about 1 foot from the gable end out to the fascia board. So what you would do is generally every 2 feet, you'd come down 2 feet from the peak, and then on center, you would make 1.5 inches by 3.5 inch cutout in the top of your rafter. Go down another 2 foot, and the reason you're doing 2 foot is because when you do siding, it's going to splice right on one of those. So you come down another 2 foot on center, and you put another 1.5 inch deep by 3.5 inch slot, and so on until you get down here. I generally do not go past where the bottom cord, if it were to run all the way out, I don't get past there. Generally, I'll stay above here, above your last bird block, and I won't have anything down here. So another 2 foot would put you, say, down here, another 1.5 inch by 3.5 inch slot. So what that does, it allows for a board called an outrigger to come through your gable truss. So say you had another truss, your next truss is over here, like this. So this outrigger would come through this truss and then butt up against this next truss and would be screwed in this way from the back and then screwed down through this truss here. So you'd keep adding those on, come out 1 foot past your gable end truss, put your screws through that second truss and then down through your gable end truss, and you do that all the way down, holding 1 foot out. I know it's not to scale, but, and then on top, you would get a longer, depending on how long your fascia board is. Say you were using an 8-inch fascia board out here, you would use the same material here, and you'd cut a 1 foot block that would stick out from the top of your peak, and you'd screw that from the back side, and then you'd add your fascia board out here 1 foot out, and you'd screw to the end, into the end of those outriggers, and you'd splice it halfway on this block here, screwing in here, and then your other fascia board coming up with screw in on the other side. So that allows you to run a fascia board and gives you an overhang out here over your gable end of your truss. And these, again, these are called outriggers. All right, hopefully this picture better illustrates what I was talking about. You have your peak block up here, sticks out a foot. You have your outriggers spaced out a foot from the edge of your gable truss, cut through the gable truss. And then they go back and tie into your first regular truss. And you would screw those in from the back side, obviously, with a couple screws through the truss. And then these would be screwed down through the top of that truss. And then when you put your fascia board up here, you would put your fascia board flush with the tops of these outriggers, and this center block's got to be held down just a little bit so the corners of it don't get higher than the top of the truss. So you'd hold it down, there'd be just a little bit of gap on the top, but it would be lined up with the top chord of the truss. So your fascia board would nail or screw out here flush with the top of these with the same cut, and then that would give you your overhang on the gable end of the wall. So if you got any questions on that, feel free to post them in the comments, and I will try to better explain it to you if you haven't got it from this. Obviously, this is the top of that gable truss coming down there with more outrigger cuts on the other side. Just like that. And then the tail, just the tail of your fascia board just kind of hangs out here, and it's held up by whatever kind of sheeting or purlin you put across these other two. But remember to keep these on 2-foot centers. So if you've got plywood that's 4 foot, you've got a place to screw it at 2 foot, and then it splices at 4 foot. So that's just really Truss 101, and I stress 101. There's could get really much more complicated the more angles your roof has with dormers or hips and valleys and all that. But if you're just building a rectangle building, it's not tough. So again, any questions or comments, feel free to post them, and I'll answer. I try to answer. Our channel's still small enough where I can pretty much answer all your questions. So we love you guys. Stay safe. Stay healthy. We'll see you soon.